All right, guys, so we had our parallel line chat on the last video. So now we want to talk about perpendicular lines. So we open that one up. Now, when we have perpendicular lines, a couple different ways we can think about it. So with parallel lines, we can just think about how they never intersect each other. And we can see that on a graph. That's not true for perpendicular lines, but we can think about that in a similar way. So perpendicular lines are lines that cross. So perpendicular lines are crossing at a 90-degree angle, or at a right angle. Now the thing is, we're not going to use measuring tools to see if that's 90. So more importantly, for our purposes, when we're trying to figure out if something is perpendicular or not, just like we did for parallel, we're going to want to take a look at the slope and the y-intercept. So the thing that has to be true about the slope is that slopes are opposite and reciprocal of each other. So opposite means one is positive, one is negative. Reciprocal means if one of them is A over B, then the other is B over A. So we do a little flippy-do, flippy-flip. Now the other thing that is like kind of less important here, like I don't necessarily need to check this second thing, is that the y-intercepts could be the same, could be different. It kind of doesn't matter. So y-int doesn't matter. It's probably more rare for the y-intercepts to be the same because that would have to be right where they cross each other, like right on the y-axis. And chances are that's not going to happen super often, but it could happen. So to check if lines are perpendicular, we really just need to check their slopes. So like we did here, the best way to check the slope of a line is to get it into y equals mx plus b. So get equation into y equals mx plus b form so that we can check their slopes. And we might have to do it twice. So for instance, if they give me a line, like line A is y equals half x plus 3. And they also give me line B is 4x plus 2y equals 8. In line A, I can see the slope already because it's in y equals mx plus b, and my slope is half. But for line B, it's not in y equals mx plus b. It's actually in standard form. So to get it in y equals mx plus b, I need to get y alone. So we'll subtract the x both sides. And so I'll have 2y equals, and I can't combine those, so I'm just going to put them in order, negative 4x plus 8. And then divide everybody by 2. And so we'll have y equals, now negative 4 divided by 2 is negative 2x. And then 8 divided by 2 is 4. And now we're in y equals mx plus b. And so the second thing, so after we get our equations into y equals mx plus b, is we want to check the slopes. And kind of two things. Are they opposite? And are they reciprocal? It needs to be both. So when I look at this one, this slope was half. When I look at this one here, the slope is negative 2. So they are opposites because the first one is positive, the second one is negative. And they are reciprocals because the first one is 1 over 2, and the second one is 2 over 1, so 2. So yes, these are perpendicular. So, yes, perpendicular, upside down T. Okay, fun. Now, the other thing that we want to be good at is writing a new equation. So like we did with parallel, they might tell me, write the equation of a line that is perpendicular to a given line and passes through the point. So if we remember that perpendicular to a given line is just code for your slope is this, although it's a little bit different. So when we did this one, this was just code for the parallel to the given line is your slope is the same as. For this one, when it says perpendicular to a given line, it is telling you about slope, but this is just code for slope is opposite reciprocal of the given line. So if the given line is y equals 2x minus 1, then when I write the new equation of my line, they've given me a point, and they're low-key giving me slope. So because they've given me the slope and a point, I'm going to put it in point slope form, which is y minus y1 equals m parenthesis x minus x1. I know my point right now, but I have to get my slope. And so because it's perpendicular to this line, and this line's slope is 2, we're going to do the opposite of that. So negative, and the reciprocal of that, so flip it, so half. So my slope is actually going to be negative half. Then we plug everything in where it's supposed to go. So the y value goes with y. We'll have y minus negative 4, so plus, equals the perpendicular slope, so negative half, parenthesis x minus the x, which is 2. And then if you want, we could put it in y equals mx plus b. This one, it matters a little less, again, because the y-intercept here, I really need for it to be different. But just for practice, we'll distribute. So negative half x, a negative times a negative is a positive, and half of 2 is 1. And then we'll subtract the 4 both sides. And you'll have y equals negative 1 half x minus 3. And I can see that they are not crossing on the y-intercept because these y-intercepts are different. But that's okay, they're crossing somewhere. Kind of doesn't matter. Alrighty. So when it comes to comparing lines, visually, parallel lines look like this. I mean, or they could be going down, but they'll never cross. But more importantly, I need to be checking slopes and y-intercepts. So if they give me a line, y equals 3x minus 1, and y equals negative 3x plus 2, those are not parallel because the slopes are different. But, for example, if I said y equals half x plus 7 and y equals half x, those are parallel because slopes are the same and y-intercept is different. I ran out of room, I'm so sorry. Perpendicular lines cross at a 90. So for instance, I might have a line like this, and then a line like that. And right here you have a 90-degree angle. But more importantly, they're opposite reciprocal slopes going on. So for example, if I had y equals 1/3 x minus 1, and y equals negative 1/3 x plus 2, those are not perpendicular because their slopes are opposite, but they're not reciprocal. But if I had the lines y equals 3/4 x and y equals -4/3 x minus 2, the slopes are opposite reciprocals because they're different signs and they're flipped over. Those are perpendicular. Now, I might just have two lines crossing each other and they're not a 90. So this one right here, this 1/3 x and this -1/3 x, those lines would cross each other, but it wouldn't be at a 90-degree angle. So we'd have something like 1/3 and then -1/3. And so this angle right here is not 90. Okay, so that can happen. Similarly, with these ones, like it was 3 and then -3, and they're just intersecting. So that happens when your slopes are just different. And they're not any special difference. Like one might be positive, one might be negative. They might both be positive, but different numbers. All those lines will intersect each other. The same line is like when I have a line and then the same one on top of it. So it's really just going to look like one line. But they kind of cross all the time. But they will have the exact same y equals mx plus b. So same slope and same y-intercept. Now, one other thing we need to try on the previous page here is writing some more equations of lines that are perpendicular. So, write the equation of the line perpendicular to y equals 2x minus 3 through the point -2, 3. So just like we did before, write the equation of a line perpendicular is just code for your slope's related to this line, but it's not the same. It's opposite reciprocal. So I'm not going to use 2 as my slope. I'm going to use the perpendicular slope, which would be -1/2. Now, if I want to put in y equals mx plus b, which is fine, I'm not going to do that first because they gave me a point. So I'm going to put it in point slope form first. So y minus the y equals m, which is -1/2, parenthesis x minus the x, which is -2, so plus 2. Then I would distribute. So -1/2x minus half of 2 is 1. And then add the 3. And so y equals -1/2x, plus 2. So if I'm going to graph both these lines, let's say the first line I'm going to do in pink is the line they give to me. So y equals 2x minus 3. I would go and plot my y-intercept at -3. And then do my slope of up 2, forward 1. We can go a bunch of times, and then I'm going to get a real nice straight line here. Then I'm going to graph my line, which I found to be y equals -1/2x plus 2. Oop, I forgot to make this one pink. Right, so I took the opposite reciprocal slope, and then I had to find my y-intercept by putting it in point slope form first. And so then I'd plot the y-intercept at 2, and then I'd go down 1, forward 2. Oh, look at that, they cross right at that spot. Which, I mean, I don't need to know where they cross, but that's kind of cute. I love it. I'm going to talk more about that next chapter. Okay. And they totally look right there like they're crossing at a 90. In fact, with this handy little straight edge, I can show it to you. So right there, you get a 90-degree angle. Okay, now when we did the last one, I showed you guys a different way to do it. So if we open this one up, kind of another way to think about how to write this equation is to graph it first and then work our way back. So write the equation of the line perpendicular to 2x plus y equals negative 2, and through the point negative 1 comma negative 2. So I can take the line that they give to me, 2x plus y equals negative 2, and actually graph that one first. Now that one's in standard form, like we were talking about the other day, and so I can graph that really quickly by finding the x-intercept. So I ignore y, solve for x, and it'd be negative 1 on the x-axis, and then ignore y and find the y-intercept is at negative 2, and then get my line. Now that's super helpful for a couple of reasons. First of all, I needed to graph the line, but secondly, now I can find my slope. So the slope of this line from here to here is down 2, forward 1. So down 2, forward 1. And then my new line needs to be perpendicular to that. So I would make it opposite, so positive, and then flip it over, so half. And so knowing that my slope needs to be half, I can write y equals half x, but I don't know the y-intercept yet, but I do know I can start at the point that they gave to me. So if I go to negative 1, comma negative 2, I start there, and then I would do my slope of up 1, forward 2, my slope of half. And it doesn't cross at such a nice point this time, but they do still cross each other at a 90. And also, like, our y-intercept isn't great. It's like right in between. And I know it's right in between because this is up a half. So it's halfway in between negative 1 and negative 2. So negative 1 and a half. Or 3 over 2. Yeah. Now, if you don't like to do it that way where you're looking at a lot of pictures and graphing and working backwards, remember there's always this way to do it algebraically up front. So this last one, what I would suggest is you try it your favorite way, and then maybe come back and see how you did. Write the equation of a line is just code for you're going to take this guy's slope and make it opposite reciprocal, and go through this point here, negative 2, comma 3. So if I do it algebraically, that 2x minus 3y equals negative 6, I have to find that slope first. So I'd have to get y alone by subtracting x. I'd have negative 3y equals negative 2x minus 6. And then divide everything by negative 3. And so I get 2/3 x plus 2. Okay, so now I can see that the slope of the line that they gave to me is 2/3, which means that my perpendicular slope needs to be negative 3 over 2, and it needs to go through this point. So I could put it in point slope form. Y minus y, which is 3, equals negative 3 over 2, parenthesis x minus x, which is negative 2, so plus. When I distribute, I'll get y minus 3 equals negative 3 over 2x. And then here when I multiply, the 2's will divide out, and you'll just be left with minus 3. And then add the 3 over, and you get y equals negative 3 over 2x plus 0. So the equation of the line that they gave to me in y equals mx plus b form was y equals 2/3 x plus 2. So that was the one they gave me, even though they don't look the same. They're just in different forms. And so I'd plot the 2 and do my slope of up 2, forward 3. Didn't get my straight edge for that one. You can tell it is not as good. And then my line needed to have an opposite reciprocal slope. I put it in point slope form and found slope intercept looked like y equals -3/2x plus 0. So it's kind of like direct variation. So I start at 0, and then I go down 1, 2, 3, forward 2 to get this line here. I was worried for a second we weren't going to see them cross. And guys, it's okay if you don't see them cross. That could happen. It's a little nicer when you do. Oh my gosh, there you go. Super cute. Okay, I'll see you later.